Antarctica, the world's greatest freezer, is melting. Trillions of gallons are draining into the oceans. Sea levels are rising. It's happened before, and it's happening again right now.
It's not a question of will sea level rise a large amount. It's only a question of how fast that will occur.
How will humans fight back before our cities are inundated?
Holding off the sea would be the major employer of the world by 2100.
Massive levees to defend our coastlines. Floating towns and cities. Vast dams connecting continents. It's our greatest challenge yet, Earth underwater. This is New York in the 24th century. Sea levels have risen by 120 feet. Manhattan is flooded. What could cause such a terrifying scenario? The answer lies here, in Antarctica, where vast amounts of frozen water are locked up in ice. Some of Antarctica's ice sheets are more than 2 miles thick. If melted, this ice would dramatically raise sea levels. And the melting has already started.
Taxi checks complete.
Scientists want to know how much frozen water the continent actually holds, and how much global sea levels will rise if it all melted. Specially equipped aircraft send radar beams deep into the ice, which reflect off the bedrock and measure the depth of the ice sheet. After hundreds of flights, they calculate that Antarctica contains over 90% of the world's ice. Together with Greenland, it's enough to raise global sea levels by an astonishing 230 feet. This is what North America would look like if all of the planet's ice melted. Europe would also shrink. London's Tower Bridge would become a solemn monument in the sea. Berlin would be flooded, as would Paris. But how likely is such a scenario? Is sea level rise reality or myth? Professor Peter Ward is a paleontologist and astrobiologist. He's written extensively on the history of life on Earth. Today, Ward wants to know what would happen to our planet if sea levels rise foot by foot.
Somebody give me a zip here.
The journey begins in the Florida Keys, a chain of islands south of Miami. He's looking for clues from the past that may help predict the future of our planet.
All right, guys, you want to go swimming? You ready?
Just a few feet below sea level are banks of coral that have been at this location for over 4,000 years. During this period, sea levels have been stable, not just in Florida, but around the world.
Who's going swimming with me? Come on, boys.
But it hasn't always been like this. A few hundred yards from shore, Peter visits an abandoned quarry that reveals startling evidence from the past.
Oh yeah, beauty. Nice. Look at this dude. Sitting right in growth position, grew straight up. Very nice. I came here at a very young 23 years of age. Our professor brought us to this quarry and said, this is a perfect reef, and it is. Look at this big coral sitting right in place. This is how corals grow straight up. And not very far offshore from us, we have these same corals living in place. And these things have to live in at least 10 feet of water. So we're sitting here. There's not been any volcanism. Nothing has lifted Florida up. How could you get this coral this high up in the air now, unless you had sea level, at least another 10 feet above this? It was the first indication to me that sea level, which I knew had gone down and come up, but I had never thought that it could be higher than it is now.
If history repeats itself, our coastal cities would be inundated. Sea level rise is not a myth. It could happen again, just as it's happened before. The beginning of the most recent ice age was 70,000 years ago. The ice sheets expanded, the planet's landmass grew, and sea levels fell. Then temperatures rose again. The ice receded. Sea levels climbed and eventually settled at today's coastlines. But global temperatures are on the rise again. This time from humans burning huge amounts of fossil fuels. They produce CO2 and other greenhouse gases that heat up our atmosphere. Whenever global temperatures rise, sea levels follow.
We have emitted so much carbon dioxide that the amount of carbon dioxide in our atmosphere has increased by about 1/3 in the last 100 years, and it is now higher than any time since at least 1 million years. We expect about 3, 4, even 5 degrees centigrade warming in this century. The warmer it gets, the faster the sea level rises. That means sea level rise will get faster and faster as we heat up the planet more.
Of course, predicting future sea level rise is difficult, as the planet has never before experienced the dramatic increase in CO2 of the last 100 years. But Professor Rahmstorf's climate model predicts a maximum 6-foot sea level rise this century, as higher temperatures kick in. One city that would face inundation this century is Miami, Florida. Just a few feet above sea level, it has virtually no defenses against a rising ocean. After 1 foot of sea level rise, these beaches would be regularly flooded at high tide. After 2 feet, many roads would be submerged. After 3 feet, if a hurricane strikes, the surging water would overcome sea defenses and cause flooding deep inland. Much of the region's coastal real estate would be ruined.
We are looking at millions and millions and millions of dollars of real estate here. And we can assume that every one of these things is $500,000 to $1 million. We've got 100 here, we've got $1 billion in a very short area through here. So our $1 billion of houses, we get 1 meter, 3 feet of sea level rise, and every single one of these houses is useless. Who's going to buy them? What happens to this $1 billion of real estate by the time we get 3 feet? I mean, it's gone. It's useless. It's just, you scrape it off with bulldozers and you just leave it here. That's what will happen. It'll just be left here.
And it's not just residential properties that will be affected.
Think of all the wharves and all the places where ships offload and onload all the goods and services. And if sea level rises even 3, 4, 5 feet, every single one of those ports has to be replaced. The cruise ship lines, there are billions of dollars of infrastructure that even a small sea level rise takes out. You got to rebuild it all over again.
After 4 feet of sea level rise, electricity supplies would be affected as coastal power plants are flooded. After 5 feet, some of Florida's freshwater resources would be contaminated with seawater, and the Everglades National Park becomes a vast bay. After 6 feet, millions of Floridians would have to evacuate the state.
So what's going to happen to Florida?
By 2100, we'll be at least 4 to 6 feet higher. So this tide, which is not a high tide, will be about here, up to here. There's no way that we can keep the sea back as it rises. Miami-Dade County will be severely diminished.
By 2100, after 6 feet of sea level rise, Miami would look like this.
There's no way to prepare for this. You can't put levees around the kind of sea level rises we're in for. We're a city that's only a little over 100 years old. We became a town, an incorporated town in 1896, so we're not that old. But we may not make it for the next 100 years.
The only way to prevent Miami from flooding would be to construct a vastly expensive system of levees surrounding the city. It would be a major engineering challenge, as Miami is built on porous ground that allows seawater to seep through. Alternatively, if Miami was flooded, the city would eventually have to be abandoned.
There are cities you can save and cities that you can't save. And the choices will be based on, can we dike it off, can we put it off, or is this too expensive, not worth the price, not worth the effort?
One city determined to defend itself against the sea is New Orleans, Louisiana. During Hurricane Katrina in 2005, large parts of New Orleans were flooded after a storm surge raised sea levels by 20 feet. The city lies several feet below sea level. Its antiquated locks and levees weren't strong enough to hold back the rising sea. As the storm pushed the Gulf's surging waters into Lake Borgne and onwards into the city's canals, New Orleans' sea defenses broke in 50 places.
We had some levee and flood wall failures in the hurricane system, and the combination of that overtopping of the levees and the flood walls that failed caused massive flooding throughout the city. About 80% of the city of New Orleans was flooded following Hurricane Katrina.
It took weeks before the floodwaters were pumped out and residents were able to return. Among them were Victory Wallace Taylor and her son Peter, who returned home to a badly damaged house.
The flood was very bad. They wouldn't let us come and see about our house. It damaged my heart a little bit because I'm afraid for the flood. Like if the flood come in again, I don't know what to do because I think I might panic this time. I don't know. It is a hard pill to swallow, you see.
To prevent New Orleans from flooding again, the U.S. government is investing billions of dollars in the city's sea defenses. Along the riverbanks, the U.S. Army Corps of Engineers is strengthening New Orleans' levees and locks. Their work here provides future insight into the kinds of construction that may be needed to protect coastal cities around the world against rising sea levels.
We learned a lot of key lessons, and some of the key lessons learned were incorporated into the designs for the Greater New Orleans Hurricane Storm Damage Risk Reduction System. And that system is a series of many different aspects. It has flood walls, it has pump stations, it has levees. There's the series that we call the multiple lines of defense.
New Orleans defense takes a unique approach against the rising water by confronting the enemy itself. The flood surge that broke its sea defenses approached the city from Lake Borgne, a lagoon east of New Orleans. It's here where the U.S. Army Corps of Engineers is focusing its efforts.
What we've done now is we moved the defense of the city out. We're about 12 miles from downtown, about 8 miles away from the 9th Ward, which is flooded. What we've done is we moved the protection from downtown, the heart of the city, left it in there, improved it. We've moved all the way out here, 8 miles out to the edge of Lake Borgne, where we now have this brand new structure which works as a primary line of defense. New Orleans is made up of the best topsoil from the United States that came down the Mississippi River and built up down here. However, back in graduate school, the whole idea was that the better it is to grow something on, the worse it is to build on. Well, this is the topsoil of the nation down here, so it's the worst possible stuff to build in. What you see behind me is the Hawken. It is a pile-driving crane brought in from Seattle, Washington, across the Pacific Ocean, down to the Panama Canal to New Orleans to build this particular gate and the barge gate. And what we've had to do is go down 60 feet through the newer material down to the old Pleistocene clay, and that is our basis. So the main wall itself goes down to minus 130 feet, and the batter piles that brace it are down to 190 feet. All tall buildings in New Orleans, the dome, everything is based upon piles.
The new seawall also has to allow ships to pass through. Dry cofferdams are put in place to construct barge and sector gates. The concrete is poured, the dams are flooded, and the gates can be completed. New Orleans' new sea defenses are costing the taxpayer a hefty $15 billion. But their design only accounts for storm surges that build from sea levels today. If sea levels rise by 6 feet, any storm surge would be higher as well, and the city's sea defenses would have to be heightened at an even greater cost. Not every country can afford to spend billions on sea defenses. In Bangladesh, many of its 150 million inhabitants live at or just above sea level. Merely 3 feet of sea level rise will have a devastating effect on the country's population.
Turns out the area of the world that would be most vulnerable to sea level rise would be Asia. The rice-growing river deltas in Asia that are very close to sea level. Even a modest 3-foot rise would put half the rice land in Bangladesh underwater.
Bangladesh has over 100 to 120 million people, and that number is rising fast. A great deal of its land just simply gets covered by water. And again, once you have salt water coming up, it's not just the land that's covered, it's the intrusion of salt. Even a 3-foot sea level rise wipes out half its rice crop. Their population's going up 1/3, and their land is being shrunk by 1/3. You know, you do the math. It's a catastrophe coming at us.
Much of Bangladesh is a vast muddy delta that can't be defended. 6 feet of sea level rise spells disaster.
It would displace millions, probably at least a few tens of millions of people. Where are they going to go? India's already built a wall between India and Bangladesh. They're anticipating there are going to be a lot of Bangladeshis starting to move, looking for a place to go, and Bangladesh itself is already one of the most densely populated countries on Earth. And then there are another 18 or 20 rice-growing river deltas in Asia, the Irrawaddy in Burma, the Pearl River Delta in China, and so forth, that would be affected in varying degrees by the rise in sea level.
By the end of the century, cities and coastlines around the world will be under siege from the rising tides. Everywhere, people will be building levees and sea defenses to fight back. But sea level rise won't stop at 6 feet. They're likely to rise at an even faster rate. As the predicted melt of Greenland and Antarctica accelerates, exposed cities may not have time to build new sea defenses. Clues about the speed of future sea level rise are found during the time of the last ice age. As global temperatures rose, the planet's ice sheets melted into the sea. Sea levels increased by a staggering 390 feet until they settled at today's levels. How fast did this happen? The answer may help predict how quickly sea levels could rise in the next century, and how much time we have to defend our coasts. Professor Rick Mortlock is one of the world's leading experts on past sea level rise. He and his team collect fossilized coral from the seabed. In the lab, they analyze and compare the exact depth and age of each sample. A clear picture emerges of how fast sea levels rose thousands of years ago.
We have 2 pieces of fossil coral that was recovered from drill cores off of Barbados. So by dating these samples and knowing the depth at which they were retrieved, we can use that information to create a point-by-point reconstruction of sea level for the last 20,000 years. There's one particular sea level rise of interest. We call it Meltwater Pulse 1A. During that period of time, we believe sea level rose about 20 meters in 500 years, or about 4 to 5 meters per 100 years.
If the same happens again, it would translate to as much as 16 feet of additional sea level rise in the next century. Factor in today's affairs, and the rise may be even faster.
If we don't get emissions under control, the rate of sea level rise will keep accelerating. And so in the next century, it's not only that we get the additional 5 to 7 feet that we got the last century, that's going to happen, but we add on to that. So now we're looking by 2200, probably at least 15 feet above, and probably 20. By 2100, the cities will know that they are doomed. The coastal cities, anyway.
If the oceans rose with accelerating speed, the planet's most exposed cities may not have time to build adequate sea defenses. Sea levels would rise by 16 feet per century. New Orleans could flood, followed by Miami.
Miami's the worst off, and New Orleans, those are 2 cities that will have to be abandoned, I imagine.
As southern Florida is lost to the sea, other coastal regions will also struggle to hold back the tides. Among them is the San Francisco Bay Area, with its 7.5 million people.
The San Francisco Bay Area is particularly vulnerable to sea level rise because of our history. Although the bay is big, it's very shallow. 2/3 of it was less than 12 feet deep. So lots of it was filled and reclaimed. We're standing here on reclaimed land, and all of downtown San Francisco, the financial district, is on reclaimed land. We've already seen 7 inches of sea level rise in the bay over the past century. We know this because the longest continuously operating tide gauge in America is at the Golden Gate. So we have 154 years of data. We're just now beginning to realize with accelerated sea level rise, we're going to have to prepare and have a new plan for how we deal with it in the Bay Area.
If sea levels rose by an additional 16 feet per century, hundreds of thousands of people would lose their homes in the Bay Area. To protect San Francisco Bay, levees would have to be built on a massive scale.
The silver lining is the engineering will create so many jobs. Holding off the sea will be the major employer of the world by 2100, I think. This is going to be worldwide. We're going to have a damn revolution.
The bay's entire coastline would have to be defended with levees in order to protect it. But in the east, the Sacramento-San Joaquin Delta would remain vulnerable because it's at or below sea level. The Delta has some of America's most fertile farmland.
The most important part is food. It's unbelievable the proportion of human food that comes from land that is at sea level, not necessarily right next to the sea, but at an elevation that will be impacted by sea level rising. Sea level rises a little, all those fields next to it, even if they're not covered by the sea, are rendered useless for human crops by the sea.
If the Delta and its farmland were lost to the sea, California's food supply would be in jeopardy. The Delta is also one of the main sources of fresh water on the American West Coast.
This is the hub of California's water supply. 26 million people drink water that comes from this estuary. That's a huge number. 2/3 of the population of California gets water from this estuary. If you raise sea level even a foot, you know, which in our mind isn't all, as geologists, that doesn't seem like much, yeah, but that's common, yeah. If you raise sea level a foot, the work that we've done suggests that you will salt up this end of the Delta, even if the levees all stay together, even if they don't fail.
If sea levels rise by 6 feet this century, local rivers will be contaminated with salt, and California's main fresh water supply will be lost. In the next century, after an additional 16 feet, the entire Delta will be claimed by the sea. But there may be a way to defend both the Delta and San Francisco Bay.
San Francisco is among the best, easiest to save. The most radical solution would be putting a big dam right across the bay under the Golden Gate Bridge.
On the ocean side, the sea is about 130 feet deep. Building a dam would be controversial and would turn the bay into a freshwater lagoon. But at a time of intense sea level rise, some may consider this the best option. Using cutting-edge technology, huge dredgers could pick up sand from the seabed nearby and deposit it as the dam's foundation. The dam's shallow incline would ensure maximum stability against earthquakes, breaking the power of the ocean waves with ease. Vast pipes and pumps would be installed to keep the bay's river water flowing out to sea. The Golden Gate Dam would cost $2.5 billion and could be heightened to deal with any sea level rise in the future. San Francisco and the Bay Area would be saved. One region that may benefit from the U.S.'s sea defenses is the Mediterranean. It's flanked by countries both rich and poor that have thousands of years of history. The Mediterranean has a unique feature, a narrowing at its mouth. The Straits of Gibraltar are between 10 and 20 miles wide, stretching from southern Spain to Africa. A dam could keep the rising water of the Atlantic separate from the Mediterranean.
There's been a plan since World War II, for instance, to put a dam between the Rock of Gibraltar and Morocco on the African side. A dam big enough that sea level rise does not affect the Mediterranean.
But building a dam here has one major drawback. Every year, the Mediterranean loses 2 feet of sea level through evaporation that is compensated by the inflow of water from the Atlantic. The dam would cut this off.
In the case that you build a dam in the Gibraltar Straits, there will not be the flow of water from the Atlantic. So in the case that you cut the flow, so there will be a evaporation, there will not be compensation, and there will be a permanent drop of the water level.
After years of evaporation, the Mediterranean would turn into a stagnant saltwater lake. Eventually, the sea would dry out.
And if then the sea level would rise, let's say another...
Sea defense engineer Peter Janssen maps out possible solutions on how to keep the Atlantic flowing while building the world's largest super dam.
I looked at the surroundings. I looked at what may be required to make a closure. And then, well, I thought it may be feasible.
One of Janssen's solutions is to use the same building techniques applied to the Golden Gates. The dam would be 20 miles long and tower 1,250 feet above the seabed, the same height as the Empire State Building. Another solution is to keep the natural flow of the Gibraltar Straits. Huge amounts of Atlantic surface water will flow into the Mediterranean. At a much lower depth, some of the Med's saltier water will be pumped back out again, keeping the sea's salt and sea level stable. The world's greatest super dam would cost $275 billion.
The total cost related to what may be the impact for all the cities around the Mediterranean, it seemed acceptable. It may be a solution.
The Gibraltar Dam would be the world's largest man-made structure, using enough rock to build 1,000 Great Pyramids. Although the dam would cut off the migration of marine life between the Med and the Atlantic, it would save the entire Mediterranean coastline from flooding.
It's certainly technologically possible. The old cradle of civilization becomes really the center of civilization. They would be the last coastal cities never affected by sea level rising.
By the end of the next century, sea levels could rise by nearly 22 feet. Some cities may be saved through the construction of super dams. Others that can't be defended are lost to the sea. Exposed countries too poor to build defenses are flooded. Around the world, hundreds of millions are displaced. It's likely that by the 23rd century, the ice sheets will melt at an even faster rate, and that the oceans will rise with increasing speed. The planet's growing population and a continuing hunger for cheap energy could make it worse.
The problem that I see again is the number of people. Every new person is going to want housing. Every new person is going to need food, obviously, and want transportation. Let's say that all of us cut our gas emissions. So 6.5 billion of us cut down by a third all our usage, and then we raise the population by a third. All those new people are just adding back to what we've cut away.
Some scientists believe that our CO2 levels could quadruple over the next centuries. It would mean reaching CO2 levels last seen over 50 million years ago, when there was no ice on the planet and when sea levels were more than 230 feet higher than today.
In the worst case, if we are so foolish as to burn all the fossil fuels so that carbon dioxide increases to more than 1,000 parts per million, then there's no question we will melt all the ice on the planet, which would mean a 75-meter or almost 250-foot rise in sea level. It's not millennia. It's not going to take thousands of years. The forcing of humans is so large that it will do the whole job within a timescale of centuries, I believe.
This is the worst-case scenario. CO2 levels triple, global temperatures dramatically increase, and the Antarctic rapidly melts. The world's coastlines are eroded as sea levels rise by an additional 50 feet by the end of the 23rd century. One rich city that would struggle to defend itself is London, Western Europe's largest metropolis. Its main river, the Thames, is tidal, and water levels vary by up to 22 feet. The Thames barrier defends the city against storm surges from the sea. If a tide is unusually high, the barrier closes its gates, and inner London is protected. If sea levels rise by 6 feet, the barrier would have to be replaced by a huge seawall upstream. But if they rise by 50 feet per century, there may not be enough time to build adequate sea defenses.
It would be a disastrous situation. It would mean you simply can't inhabit the coastal areas because you will have a continually changing sea level. So we really do not want to go down that path.
If CO2 continues to increase at a growing rate, 50 feet of sea level rise per century is a distinct possibility. The swiftly rising oceans would bypass any new seawalls. London and large parts of England would be flooded within a few centuries.
The worst case scenario is when we have maybe 4 to 6 feet within a decade. That's not the kind of thing where you sort of sell your houses and say it's going to be okay. But you're trying to get out of there without drowning. It's going to challenge the existence of civilization.
One of London's most famous landmarks, the Tower Bridge, would become a somber outpost in the sea.
I mean, there would be a degree of panic that we cannot imagine as each country tried to figure out how it somehow could survive.
Rising oceans would seep underneath obsolete levees or breach areas where there wasn't the time or money to strengthen seawalls. The rapidly rising sea levels would soon overwhelm large parts of continental Europe. By the time all of the Antarctic's ice has melted, Denmark, the Netherlands, and large parts of northern Germany and France will be lost. Significant sea level rise may turn Berlin into a coastal town within centuries. Another 100 years, and the city would be lost to the sea. The rising sea would creep up the River Seine and find its way to Paris. With an elevation of 115 feet, the French capital would be vulnerable to sea level rise. After all of the planet's ice is melted, it will flood.
The affluent countries would try to protect their borders against millions and millions who would be leaving the areas most severely affected. But the stresses associated with migration on this scale are unimaginable.
The meltdown of the planet's ice sheets would completely transform our world. But even as our coasts are pushed back by the rising oceans, resourceful humans would try to adapt. There are already plans to rescue New York. Manhattan Island is flanked by two fast-flowing tidal rivers. The entire city is directly exposed to the North Atlantic and extremely vulnerable to sea level rise. Professor Malcolm Bowman is an oceanographer and expert on the effects of sea level rise in New York.
If the worst case scenario, the rapid meltdown of the ice sheet on Greenland, the West Antarctic ice sheet, were to happen extremely rapidly, the future of New York City is in peril. So the city has two options. One, either build massive defenses, or two, start evacuating the city and its population to higher ground.
The flooding of New York's underground installations would only be the first in a series of catastrophic events. After the first 6 feet of sea level rise, parts of lower Manhattan would be submerged. If sea levels rise by 50 feet, the water would move into Times Square.
Behind me is the Manhattan Bridge. With sea levels rising 250 feet, that bridge would have seawater lapping around the roadway. New York City as we know it would not exist.
But there is a way that New York might adapt even to extreme sea level rise. The idea is to build on water. Here in the Netherlands are several communities of floating houses. Koen Olthuis is a visionary architect who believes these houses are the beginning of a new trend in design and construction.
So what you will see is that people go and design floating apartment buildings and really floating structures like 200 by 200 meters with roads on top of it and with cars on top of it and houses.
Such floating cities could be built with a new lightweight material that's like a concrete sponge.
The beauty about floating cities is that you don't have to protect them from nature. They just go on with nature, they live with nature. And they will just go up and down with the water.
Olthuis has designed a seawall to protect Manhattan, with floating districts attached to it.
New York, we're going to build a new Wall Street around it, around Manhattan. So we can redesign the city around it, or even having floating leisure around it, floating agriculture.
A floating New York is still in the concept stage. But one day, this may be the solution for hundreds of coastal cities facing inundation.
The best silver lining of the whole thing to me is that it will require a united world. A world war against sea level will have to bring all of the squabbling governments to act together. The sea doesn't care what your national boundary is. It's an equal opportunity flooder. We will have to, as a planet, come at this in a united fashion.
Whether it's the construction of massive seawalls or super dams, sea level rise will happen. The question is not if, but how fast and how much our oceans will rise. Much will depend on our own CO2 emissions. Humans will need all their ingenuity to meet the world's greatest challenge yet.
When 7 p.m. feels like this, you must be watching the National Geographic Channel.